Here at Agrivert, we specialise in cost-effective and sustainable organic waste management solutions. Over 20 years, we've developed a leading position in the UK organics treatment market. We operate in a unique portion of this market, simultaneously designing and constructing complex facilities for others, whilst building and operating our own food waste, green waste and sewage sludge recycling facilities. Today, Agrivert works with over 30 UK local authorities, providing them and numerous food preparation and waste collection businesses with unrivalled waste recycling solutions. Our AD facilities produce enough green electricity to power 25,000 local homes and businesses each year. This short story will concentrate on anaerobic digestion. We will explain the journey that Agrivert takes to convert food waste to renewable power and biofertiliser. Anaerobic digestion is a series of natural biological processes that happen in the absence of light and oxygen. These mimic the digestion system of a mammal, such as a cow, making it possible to break down organic matter such as food waste to produce biogas for electricity and a rich biofertiliser. Here is where it all starts. Food waste is delivered to us in both solid and liquid forms, and we accept delivery of these materials in many different vehicle types. Each of our facilities handles approximately 60,000 tonnes of food waste each year. That's enough to fill 25 Olympic swimming pools. The solid food waste that we accept comes in all shapes and sizes and is all generally contained within some form of primary packaging. This waste is tipped into an automated food reception bunker. A walking floor mechanism and screw conveyors transport the packaged food waste from our reception bunker into the depackaging equipment. Our bunkers are sunken beneath ground level and are completely sealed, thus safely containing all food wastes and any liquids that may arrive with it. Whole loads of liquids that we accept into our site are emptied into underground liquid storage tanks. The first part of processing the food waste is to remove any packaging that won't digest before we feed the organics into our digestion tanks. Our hammer mills use a series of hammers and knives to shred and chop the material, whilst creating a wind vortex to separate the packaging fraction from the organics. This machinery is extremely robust and can be easily accessed to remove any problem materials that may stop it from functioning effectively. The packaging fraction that our hammer mills have removed is passed through a further machine for squeezing. This removes any liquids that the packaging may have brought with it. This results in a consistent and fairly dry product that can be sent on for energy recovery. Now that we've removed all non-digestible materials from the food waste, we're left with a clean organic product. The introduction of processed liquids into the depackagers means that the organic fraction is now a thick, pumpable substrate, sometimes known as soup. This has a dry solids content of around 16%. Upon leaving the depackagers, our soup is passed through into its first storage facility, known as the buffer tank. The first job of our buffer tank is to blend and homogenise the soup to ensure that it is easily digestible. The next is to prevent any grit flowing through into the digesters, which we know can cause serious problems. We've designed an innovative grit removal system, which is supported by easy access to the tank for when cleaning is required. Another important benefit of the buffer tank is that it provides enough upstream capacity to ensure that we can continue to feed our digesters regularly. Examples of when this is particularly useful is if we undertake planned maintenance or perhaps experience issues with waste supply that are outside of our control. odour management is an important part of our day-to-day operations. The natural odour produced by the operation we undertake in our waste reception hall is contained within the building using negative air pressure and an efficient odour management system. This air is regularly exchanged for clean air. The odorous air that we remove is passed through a wet scrubber and absorbent medium such as wood chippings that can be found in our external biofilter. This process effectively removes odour from within that air before we release it to the atmosphere. The next part of our process is digestion. Our complex pumping mechanisms move the clean food soup into our digester tanks. We cultivate a live and healthy biology within each of our digesters. Our facilities typically have 5 concrete digestion tanks containing approximately 5,500 cubic metres of material in each. When designing a new AD facility, all of our tanks are designed and custom built to suit the needs of the site footprint and the required digestion capacity. All of our tanks are also designed to work at high temperatures, facilitating swift and efficient digestion. This is achieved by heating rings which we run around the inside of the tanks. We warm these using the heat that's produced by our gas engines. The material within our tanks now has a dry solids content of around 5 to 6% and contains roughly 4% volatile solids per metre cubed. We use mechanical stirrers to constantly agitate and stir the material, making sure no crusts are formed on the surface and that the biology can thrive within all parts of the tank. We typically retain this material in our digester tanks for approximately 75 days, or until it's completely digested. However, this can be as low as 30 days depending on the design and digestion requirements of the facility. Throughout this retention period, we harvest the biogas that's naturally produced within the roofs of our digesters or in a purpose-built gas storage vessel. Depending on what we're using as a feedstock, on average our plants produce between 140 and 160 metres cubed of biogas for every tonne of waste that we input into the system. Our biogas is cleaned to remove any elements that might damage our CHP gas engines. The resultant clean methane is then combusted to create renewable electricity. The renewable power we produce is fed onto the national grid to power local homes and businesses. On average, each of our facilities produces enough electricity to power 5,000 to 6,000 local homes. After we've dealt with the gas in our digesters, we are left with a rich organic digestate. This is a thick product that contains many organic nutrients such as nitrogen, phosphate and potash. If our facilities are in an area which has strong agricultural markets, such as the UK, digestate is highly valued by farmers for its nutrients. These are products that farmers would traditionally have added to their land via petrochemical fertilisers. In markets where a strong agricultural demand does not exist, digestate can be further treated through solid separation and water treatment, recycling the resultant clean liquids back into the environment. Agrivert are very proud to build successful, efficient and best-in-class facilities. Our average power production statistics speak for themselves. Agrivert. Environmentally, financially and technically sustainable.